So Richard, can you just explain very briefly and succinctly what the latest understanding, the current understanding of how the mechanism of evolution by natural selection actually works?
The word neo-Darwinism is used as opposed to paleo-Darwinism or Darwinism. Darwin knew nothing of genetics. Darwin's genetics, the genetics of Darwin's time, was completely wrong. Everybody except Mendel interested. Mendel discovered modern genetics. He was a contemporary of Darwin, but Darwin didn't know about it. In Darwin's time, it was thought that the maternal component and the paternal component blended, rather like mixing two pots of paint. So you would get, say, red paint and blue paint, mix them together, and you get purple. And of course, if you mix purple and purple, you don't reconstitute red and blue. Whereas you can tell, anybody can see that actually you do, in effect, reconstitute red and blue. So that's the big difference between neo-Darwinism and Darwinism. Genetics is particulate. That's to say, genes don't blend. Genes are like, well, in Mendel's time we would have thought of them as little balls. Now, of course, we know their DNA. That doesn't matter. The important thing is they don't blend. They remain intact from generation after generation after generation. Genes are things that you can count. They have a frequency. In Darwin's time, there was no such thing as a gene. There was nothing that had a frequency. Heredity was governed by, they thought of it as like substances, mixing substances. There's nothing you can count there. The neo-Darwinian revolution, which sort of began in the 1930s and continues to this day, in neo-Darwinism, we have frequencies of genes. Every gene has a frequency in a gene pool, and that frequency can change as the generations go by, and that is the modern understanding of evolution. The modern understanding of evolution, which is really a bit different from Darwin's, evolution is changes in frequencies of genes in gene pools. And the genes that are good at surviving are the ones that become more frequent in the gene pool. The genes that are bad at surviving become less frequent in the gene pool, obviously. And what does success in surviving mean for a gene? It means the gene is good at building bodies. That's how genes survive or don't survive. At any one time, we think of a gene pool as a thing where the genes are kind of being stirred around. But at any one time, the genes are all locked up in individual bodies, and the bodies that survive pass on the genes, so the genes that make them survive, the genes that equip them, equip bodies to be good at surviving, are the ones that become more frequent in the gene pool. And so what the result of that is that as the generations go by, what we see is bodies that are better and better at surviving and passing on genes. And the way I put this in The Selfish Gene is that an animal is a survival machine for the preservation of its genes.